All right, 8th graders, your next activity after the windmill challenge is to create a pull toy. This is an advanced activity. Honestly, I'm not sure if I'm going to get you all through it, but we're going to give it a shot, see how far we get. I anticipate great results with many groups, but this is one last mechanical activity before we get into computer programming. In computer programming, we're going to take some motors and sensors and do some applications with our mechanisms there. So let's look at this assignment. This is off the Project Lead the Way website. The introduction is a pull toy is pulled along the ground and a movement is produced such as a head nods, a tail wags, or a figure bobs up and down. The pull toys use mechanisms to transfer energy from the wheels to the characters that define them. The procedure for this activity goes as follows. With your knowledge of mechanisms, you and your partner will use the design process to design and build a mechanism or a series of mechanisms that will meet the following criteria. The mechanism is to be built entirely from our VEX parts. This is Fisher Technic, but we're using VEX. Mechanism is to be built entirely from VEX parts provided in the lab. The mechanism is to be built on a small four-wheel chassis capable of being pulled across a tabletop surface. The movement of the wheels will make the toy move. A geared mechanism attached to the wheels will make another part of the pull toy move. I'm not going to worry about sketches, but I will share an example with you. And first period should probably get a kick out of this. All right, here is a start of a pull toy. And they have used their base plate to make their chassis. And it has 4 wheels. Now, I don't have enough of these types of wheels for all the groups. They kind of look like rollerblade wheels. I do have some others that are available, but we may have to borrow them off of other structures. So if you need them, we'll get them out on an as-needed basis. I do have these larger wheels, but we're going to use up these rollerblade style wheels first. So you do have to have 4 wheels on a chassis. You do have to have a couple of the long axles, which I keep in a tub. I have a tub full of long axles. They're over by the vise. We have so many of them, we do use them to make medium-sized axles as well. You can get those on an as-needed basis if you are working on the pull toy. Now, this has a couple mechanisms on it. There is a chain drive that comes off the wheels. So the wheels actuate a chain drive, and then this chain drive in turn actuates one of the mechanisms that you've learned about in class. And if I could tilt that, oh, I can't get a good angle there, tilt that over there, you can see that it is cam and follower. So you're using the wheels, and you can use a chain drive, or you can use gears to provide rotary motion, and then the rotary motion is going to actuate a mechanism that makes this emulate a pull toy. So think about something that a small child would have, and you can hear and see the cam lobe as I'm turning this. You can hear and see it just barely. It's being actuated. Now this group has a little ways to go. You can see it's very wobbly. So like the windmill, it does have to be rigid and stable. We do need to show great care in our parts because across 6 periods we have limited quantity. So I anticipate that we'll run out of the rollerblade style wheels and that we'll have to move on to these larger wheels. These larger wheels I use on the Clawbots, which is for a programming activity that we do towards the end of the quarter. And so we may have to borrow these off of the Clawbots. Once we are done with these need to get returned back to the Clawbots so that we'll be ready for that activity towards the last couple of weeks of the quarter. Just like with the windmill challenge, when you are working on this, there will be many small parts out. You need to be responsible and make sure that you get them put in the right place at the end of the period. Be very careful to keep the toolboxes organized. Be very careful to keep the lab carts organized. Mechanisms, you can borrow those from your class period. If we run out, we'll look at the large cart of parts to take care of those as well. I will direct you towards this activity as you're finishing up the windmill challenge. I've had so many groups get through scenario A already that I need to be ready for when they wrap up scenario B on the windmill challenge so that they're ready to move on. So, until next time, good luck.